Hi, this is another video in our series on vectors. This time we're focusing on the cross product. This is for high-level students only. Cross product is a result of a process of finding a vector that is perpendicular to both the vectors involved. That's a kind of a complicated definition, but basically, if you've got these two vectors here, v and w, if we take the cross product, we're going to find another vector that's perpendicular to both of them. Here's one way to work it out. Okay, you can see this is a vector with three rows, one column when you work out these numbers, but that's hard to remember. Easier way, it's a bunch of determinants like that. That's hard to remember. This is the format you'll see the equation in most of the time. It's the determinant of the ijk vector, and the ijk vectors are in the first row of the determinant, and then we've got the first vector going horizontally across, and the second vector as well, horizontally across. That's just the hard thing to remember, that these vertical vectors, vertical column vectors, become the rows of the matrix determinant here. So this is the best formula to remember. There is another formula that's quite different, that the magnitude of V cross W is magnitude V, magnitude of W times sine theta. You might remember dot product was magnitude of V, magnitude of W cos theta. But this is a little bit different, and that's a useful thing to remember later on. We'll see an example soon. The other thing to remember is you can work out the area of a triangle. If you represent two of the sides as vectors, then the magnitude of the cross product times a half will give you the area of the triangle. If you look at this, half A, B, sine C, two sides and the angle in between them. That's what it's all about. Okay, hopefully you made that connection already. Just out of interest, that's what your formula book looks like. You've got the cross product, you've got the two different formulas there, and you've got the area of a triangle. That's a picture of my hand. V cross W is perpendicular to both V and W. The easiest way I find to look at it is a right-hand rule like this. Some people do a right-hand screw rule or a right-hand palm rule. I find if I put my fingers like that, the first vector, the vector on the left-hand side, so V in this case, is your thumb. The second vector, the vector on the right-hand side, W, is your index finger, pointer finger. And then your middle finger is 90 degrees to both of them. That shows you which direction it's going in. Okay, you can look up some other ways to do the right-hand rule if you want, but that's the easiest way I find. And the other important property to remember, I've already told you about this, is that the magnitude of the cross product gives you the area of the parallelogram formed by those two vectors. Just remember, magnitude of cross product is magnitude of V times magnitude of W times sine theta. You'll remember this anyway, because area of parallelogram is base times perpendicular height. If W is the base, the perpendicular height would be V sine theta. Okay, here's a couple of examples. Just calculate the cross product. Just show us how to do it. Well, we use the formula, the determinant form, multiplying that out. Remember, when you get a 3 by 3 determinant, you cover up this row and column. So it's I times the determinant of these four minus j times the determinant of these four here, and then k times the determinant of these four. Right. Working that out, it's AD minus BC each time. 6 minus 4, minus 4, minus 1, 8, minus negative 3. That's your answer. 2i plus 5j plus 11k. If you want to write it in column form, you can do that too. I didn't do that here. So you could also write it in column vector form, 2, 5, 11. Find all the, here's a second example. Find all the vectors parallel to both of these. I said parallel, I meant perpendicular. Perpendicular, so you know that the cross product is perpendicular both of them, so let's find the cross product. Okay, same method, determinant method, that's our answer. So that's one vector that is perpendicular to both of them. What do you mean all vectors? Well, if one vector is perpendicular, every vector that's parallel to it is also perpendicular. So any vector in the form k times our cross product here is going to be perpendicular perpendicular to both these vectors. Okay, I'll fix that in a minute. Oh, two more examples. Oh no, yep. Okay, here's a question. Maybe you want to stop the video right now and see if you can do this and come back in a minute and I'll show you the answers. Okay, here's the answer to the first bit. Okay, find the magnitude of A and the magnitude of B. You should remember this really easy. It's just that Pythagoras type formula. There's your answers. Okay, so it's just the square root of each of the components squared and summed together. Dot product, you'll remember, is 2 times 1 plus -1 times 0 plus 3 times -1. And the answer is -1. Cross product, we use the determinant formula, and there is our cross product. You remember scalar product, dot product gives you a scalar answer. Cross product is called the vector product because you got a vector answer. Okay, remembering that A dot B is magnitude of A times magnitude of B cos theta, find cos theta. Well, we know A dot B minus 2, we just worked that out. We know the magnitude of A and the magnitude of B. So cos theta is just going to be this divided by this. Okay, remembering that A cross B is magnitude of A, magnitude of B sine theta, find sine theta. Okay, well, that's A cross B. That's our magnitudes of A cross B. So sine theta is just going to be that divided by what we had up here. Okay, check that it works in this trig identity that you all know. It does. 1 squared plus root 27 squared is 28. 28 over 28 is 1. Okay, one more question. Find the area of a parallelogram, ABCD. There's a parallelogram, there's ABCD. I haven't drawn in 3 dimensions because I can't, but I don't need to. We can just do this. Okay, there's a couple ways you can do this, but the easiest thing I find is ABCD. We're going around lettering our vertices around the parallelogram. We want to find the cross product of 2 vectors. Which 2 vectors am I going to choose? I'm going to choose those 2. BA and BC. I have to have an angle in between them. So it has to be BA and BC. They have to start from the same place. I could do CB and CD, or I could do DC and cross DA, or I could do AB cross AD, but I don't have all the information I need. I only have A, B and C. I don't know D. So the best I can do is BA cross BC. That's what I just explained to you there. I could use these other methods, but this is the information that I have. Okay, so BA is A minus B. BC is C minus B. That's what they are. We cross them together and we get -8, 8, 0. Find the magnitude of that. Square root of 64 plus 64, or 8 root 2. Okay, that's the cross product. That's what you can use it for. Enjoy. See you with more videos soon.